All right, here's a lesson on graphing rational functions, and we're going to focus on finding the vertical asymptotes and the zeros. A discontinuous function is one that has a gap or a break in it, whereas a continuous function does not have any gaps or breaks. We've already looked at linear, quadratic, polynomial, exponential, logarithmic functions, which are all considered continuous. Example 1, we want to graph this rational function, and we're going to first find the x-intercepts. So to do this, we set the numerator equal to 0 and solve for x. So we have x minus 3 equal to 0 and x plus 2 equal to 0. And then we solve them for x. So we add 3 to both sides. So we get x equals 3. So as an x-intercept, it's 3, 0. The second one, we're going to subtract 2 from both sides. So we get x equals negative 2. So as an x-intercept, it's negative 2, 0. The second thing we want to do is find the vertical asymptote. This is where the denominator equals 0. So we set the denominator equal to 0, so x plus 1 equal to 0, and then we solve for x. So we subtract 1 from both sides. So the vertical asymptote is at x equals negative 1. So here is that vertical asymptote graphed out at x equals negative 1. Then we have our x-intercept at 3, 0 and negative 3, 0. And then to find the rest of the ordered pairs, we could just create a t-chart and find some more ordered pairs, and that'll be in a later part of our lesson. So again, here is our curve and our other piece of our curve for this function. We're going to follow these steps to find the x-intercept and the y-intercept. So to find the zeros or x-intercepts, we set the numerator equal to 0. So here is our numerator example, and we would say x minus 1 equals 0, and we solve it, and we get 1. And then x plus 2, we set it equal to 0, and we get negative 2. So those are the ordered pairs. To find the vertical asymptote, we set the denominator equal to 0. So here's our denominator for this example. So we'd say x plus 2 equal to 0 and x minus 3 equal to 0, and then we solve them for x. So we get negative 2 and positive 3. So again, to find the vertical asymptote, we set the denominator equal to 0. To find the x-intercepts, the zeros, we set the numerator equal to 0. So here's a second example. So we first want to find the zeros of the numerator. What's different about this problem is it's not in factored form, so we do have to factor it. And this is a quadratic trinomial where a is 1, so we can set up our diamond and we say what are the factors of AC that add to B, and those are positive 4 and negative 1. So in factored form, it's x plus 4 quantity, x minus 1 equals 0. So then we set those factors equal to 0 and solve for x. And then we solve by undoing, so we subtract 4 and add 1. And then we write them as ordered pairs. Negative 4, 0, positive 1, 0. So here's our x-intercept and x-intercept. Then we head down to the denominator and we set the denominator equal to 0 and then solve for x. So we subtract 3 from both sides and we get our vertical asymptote at -3. Then to find the additional points for this curve, we evaluate the function. Example 3. Here's our numerator. We have to factor it. So just like the last problem, we're going to set up our diamond. What are the factors 6 that add to 7? And that's +6 and +1. And then we set those factors equal to 0 and solve for x. So our first x-intercept is at -6, 0. Set our second factor equal to 0. Solve for x by subtracting 1 from both sides. And then write that as an ordered pair. So there's our two x-intercepts. Our vertical asymptote is when the denominator makes it 0, which is undefined. So we subtract 3 from both sides. So our vertical asymptote is at -3. X equals -3.